We're looking at the Chapter 12 review, which comes from your textbook. It's that selection of problems. Some students requested to start with just giving you the answers. So these are the answers to the problems that we will be going over. If you'd like to at least copy those down. Remember, it's not necessarily the answers that I'm worried about, it's you're being able to get to those answers. So that's what you should have. So if you'd like to get those answers, you can go ahead and pause the video now, copy those down. Otherwise, we're going to start working through some of these problems. So we start with 12.1. We need to determine whether the solid is a polyhedron. If it is, name the polyhedron and explain the reasoning. So the first one, let's just think about a polyhedron. A polyhedron is going to be made up of polygons. So anything that's not made up of polygons or has something that is not a polygon will not be a polyhedron. So we could take that approach and think anything with a circle is not a polyhedron. So number 2 is not, that is a sphere. Number 4 is not, that is a cylinder. So those are automatic no's. Now number 1 is a yes, and if we look at the base, we see that it's a pentagon, and we're going to call that a pentagonal prism. And the reason is it's made up of all polygons. We have a pentagon on the top and bottom, and then we have rectangles going all the way around. Number 3 is a yes also. It is a triangular pyramid. Also makes it a polyhedron. Then we go to number 5. Determine the number of faces on a solid with 6 vertices and 10 edges. We have Euler's formula for that. F plus V equals E plus 2. The faces plus the vertices equals the edges plus 2. And we have 6 vertices, 10 edges. And we're solving for F. We can see that we have F plus 6 equals 12 by adding those two. If you subtract, you get F equals 6. It's also what value here would get, if this true, well, I need 6 more to get 12 on either side. So there'd be 6 faces. We don't have to worry about drawing that necessarily. We just need to know Euler's formula. Number 6, we're looking at the surface area of a prism. Surface area for a prism is 2 times the base area plus the perimeter times the height. If I draw my base off to the side, it's 6 by 5, or 30 for its area. Its perimeter is 6 plus 5 plus 6 plus 5, or 22. The last value we need is the height. That's the value we haven't used yet. That's the distance between the bases, and that's going to be 4. So we find other values, now we can solve it. Now, before I finish solving it, in this problem I used the bases being this rectangle on the bottom. It doesn't necessarily have to be that one in a rectangular prism. We could have chose the front and back. The key thing are the bases are congruent sides, congruent parallel sides, we should say. And we're going to see that, for example, on the next problem when we get to it. But in this one, we have 2 times 30 plus 22 times 4. We get 60 plus 88 gives us 148 feet squared. Okay, number 8. We're still going to use 2 times the base area plus perimeter times the height. In this case, our bases are the 2 hexagons, kind of like a front wall and a back wall. Now, those are our bases because they're congruent and parallel. We couldn't use the rectangles on the top and bottom, mainly for a reason. In a prism, all of those walls that go around will need to be rectangles. So we should just learn to recognize that it's going to be if it's something other than a rectangle, we need to treat that as the base. So our height is 8. We're now going to take our hexagon, and we need to find the base area and then the perimeter. Well, since it's a hexagon and all the sides are 6, I can do 6 times 6 to get its perimeter, which is 36. The base area is an area of a hexagon, which, let's just go to a different page real quick. Let's review area of a hexagon, or really area of a regular polygon. The area of a regular polygon is 1/2 the apothem times the number of sides times side length. Since I know 6 is my side length and I know it's a hexagon. I already have two of the values. What last thing I really need is the apothem. Now the apothem is a line, the distance from the center to the side of the polygon that's perpendicular to it. So the way we get that is we draw a triangle here, then we cut that triangle in half, and it happens to be in a hexagon. This turns out to be a 30, 60, 90. 6 was the entire side. We take half of it. That's now 3. Now within the 30, 60, 90, I would multiply by root 3 to get that leg, because it's the shorter leg to the longer leg. So now I know my apothem is 3 root 3. So I have 1/2 times 3 root 3 times 36. I could take half of 36. It's going to be 18 times 3 root 3, and I eventually get to 54 root 3. Now, we need to know how to solve this type of problem. Yes, it deals with something we did last chapter in dealing with areas, but we're going to need that if that happens to be a base, and you're going to see that. But the way this changes, if it's a hexagon, I could change this side length. If I did, that number would change, that number would change. Still has 6 sides. Now, that one we'll easily see. To get the apothem, we'll have to break out that triangle and see it. But you also may notice there's a pattern that exists, that the apothem is in fact half the length of the side root 3. So this is 6, so this was 3 root 3, or half of 6 root 3. If this was 4, this would have been 2 root 3. If this was 8, this would have been 4 root 3. And that's a pattern that exists. Now, maybe it's not something we rely on, but it's something that does help when we need to solve it. So 54 root 3 I found is my base area. Let's get back to our problem here. So now I go 2 times 54 root 3 plus the perimeter, 36, times the height, which was 8. Now 2 times 54 is 108, and that's root 3. And then 36 times 8 is 288. Now if I'm just writing this in simplified radical form, I will leave my answer as this, and it's meters squared. If I then want to write it as a decimal, which it hints here, I will take 108 times root 3 and get, it's about 187.06. Add that to 288, and I get an answer of about approximately 475. We'll say 06 meters squared. Now, if the problem asks you for an exact answer, you would leave it with the radical, 108 root 3 plus 288. That is the most exact answer we have. The 475 is actually an approximation. So be careful when you read the question to what it's asking for on your test. It just need to be left in the radical form. Okay, we go down to number 9. Here we're looking at finding the surface area for our cylinder, and we're going to do that actually for all 3 of these problems. So we'll just write the formula one time. For surface area of a cylinder, we have 2 bases, so that's 2 times pi r squared. And then the lateral area is 2 pi r, which is circumference times height. So really all we need is a radius and a height. So for number 9, we're going to do 2 pi times 2 squared plus 2 pi times 2 times 11. 2 squared is 4, times 2 is 8. 2 times 11 is 22, times 2 is 44. So I get 8 pi plus 44 pi, which is 52 pi centimeters squared. We then could change that into the decimal. Like it says, round to 2 decimal places. 54 times pi would be about 169.65, and we could just leave it there. I'm just going to leave it in terms of pi, because that would be an acceptable answer for what we need. Okay, number 10, it's going to be 2 pi times 1 squared plus 2 pi times 1 times 1, and that's with radius 1, height 1. 2 pi plus 2 pi gives me 4 pi meters squared, and again you could then take 4 times pi and get that's about 12.57 as a decimal. Okay, last one, 2 pi times 17 squared plus 2 pi times 17 times 5. I have 17 squared is 289, times 2 is 578 pi. I add to that 17 times 5 times 2, oops, space. 17 times 5 times 2 is 170 pi. I then add those two together and I get 748 pi millimeters squared, and if I then wanted that in terms of pi, it would be about 230, looks like 2,349.91 would be 2 decimal places.
There are still
Okay, now we go down to number 13. Solve for x given the surface area S of the right prism or the right cylinder, round to 2 decimal places. So now they give us the surface area, we need to find a missing value. 13 is a good one because there's really two approaches to it. I want to go with the one I would recommend that does make it a little bit easier for solving. I mentioned earlier for a rectangular prism, you could change which ones you wanted to use for the base. I'm going to assume I'm going to use this side and then this side here as the bases, because if I did that, 2 times the base area plus perimeter times height, my base area would be 4 by 4, or 16, and my perimeter would be 4 plus 4 plus 4, or 16. It's a coincidence there. And x would become my height. So much so, when I solve it now, I have this, and it's only x in one spot. Now, 192 equals 32 plus 16x. I get 160 equals 16x, and x is 10 inches. Now, let's go back and let's assume that I use this piece as the base. So if I did that, my base area would be 4x. My perimeter would be 8 plus 2x, because it'd be 4 and 4, x and x, so that would be the total for perimeter. So now 2 times 4x or plus 8 plus 2x times the height is 4, and that's equal to 192. So now 192 equals 8x plus 32 plus 8x. That becomes 192 equals 32 plus 16x, which looks very familiar to what I had here, which we still see comes out to be 10. So we still get the same answer, but it was just a little bit easier to solve. Maybe you didn't realize that. As long as you get the base area and the perimeter correct and the values, it's still going to come out correct, but just something to be aware of. Now 15, I have my cylinder, and the formula for a cylinder is 2 pi r squared plus 2 pi r h. Now for this one, I'm going to use 754 as my surface area, is equal to 2 pi times 6 squared plus 2 pi times 6 times x. Clean this up a little bit. 6 squared is 36, times 2 is 72 pi. And then I get 12 pi x for my last term. Now, what I'm going to do, which may make things a little bit easier, is I'm going to try to divide 754 by pi. And if I do that, I get it's about 240.00. Now, this is an approximation, and would be perfectly fine just calling this 240 when we divide it by pi. And by doing that, I've actually divided everything by pi, and hence gotten rid of it. So now it's 240 equals 72 plus 12x. I can subtract 72. I get 168 equals 12x, and then divide that by 12, and I get 14 feet. And it is an approximation, and maybe we should have made it 24.01 or 240.01, but we're approximating, and we'll be perfectly fine with that. Okay, number 16. We're now looking at surface area in a pyramid. Surface area for a pyramid is the base area, and we got one base, plus 1/2 the perimeter times slant height. Now our base area is going to be 5 by 5. And you may notice we don't have a 5 here. When they only give us one of the values, we're going to take the assumption that it is a square or it's a regular polygon. So it would be 5 by 5 in this case, 25. Perimeter, 5, 5, 5, and 5 gives us 20. And this other 5 is our slant height. Notice that's on the outside of the pyramid. It is not a height on the inside. That would be height. That would be used for volume. But slant height goes on the outside. That's the one we need. So I get 25 plus 1/2 20 times 5. 25 plus 10 times 5. 25 plus 50 gives me 75 inches squared. For number 17, this one we have to be careful because we now have a regular triangle for our base. It's 2 by 2 by 2. And the base area, we have to be careful how we calculate it. Now, first off, the perimeter is just going to be 6 because we add up all the sides. But base area, now, we could do the approach we did earlier with 1/2 the apothem times the number of sides times side length. Or we're really just looking for the height here. Because I know the base of this triangle is 2. The area of the triangle will be 1/2 base times height. Now, by cutting this in half, it's actually a 30, 60, 90, where this becomes 1 and this becomes root 3. So the area is 1/2 2 times root 3, which we can even see simplifies to be root 3. Last piece we needed would be slant height, which we know is 5. So base area plus 1/2 perimeter times slant height becomes root 3 plus 1/2 6 times 5. Root 3 plus 3 times 5, I get 15 plus root 3 centimeters squared, and that would be acceptable in terms of the radical. If you wanted to then write that as a decimal, and then once we take 15 plus root 3 and we write it in decimal form, it does come out to be 16.73 centimeters squared. Okay, now we go to number 18, which is now a pentagonal pyramid, the pentagon. We're still going to have to find the base area and the perimeter. So let's start with those. The perimeter, I have 7 for each side. I have 5 sides, so it's going to be 35. Then the base area is 1/2 the apothem, which they give us, 4.8, times the number of sides times the side length. Now, the number of sides and side length also happen to be the perimeter. So instead of writing 7 times 5 and running out of space here, I could just write 35 because that's what it's going to be. So I'm going to do 4.8 times 35 divided by 2, and I get that the base area is 84. So my surface area is going to be the base area plus 1/2 the perimeter times slant height, which I get 84, plus 1/2 35 times 15. 35 times 15 is 525. We divide that by 2. We get 262.5. Then we can add that to 84, and our answer comes out to be 346.5 meters squared. Number 19, we're looking at the surface area of a right cone. So our formula for this one is pi r squared, because we have one base, plus, like we did above, 1/2 perimeter times slant height. But since perimeter is circumference, 2 pi r, it just becomes pi times r times L. So it's pi times 3 squared plus pi times 3 times 8. I get 9 pi plus 24 pi, and that comes out to be 33 pi inches squared. plug that in the calculator, and that is approximately 103.67 inches squared. Number 20, we'll use the same formula, but be careful here because they give us the diameter is 2. We want the radius, which is 1. Pi times 1 squared plus pi times 1 times 1.7. That becomes pi, because it's just 1 pi, plus 1.7 pi. I add those together, it is 2.7 pi meters squared, and as a decimal, that is 8.48 meters squared. Number 21, we have to be careful before we solve because we don't have slant height here. We actually have the height. So in this case, you would use Pythagorean theorem to find L. L squared equals 12 squared plus 9 squared. We get 144 plus 81, which gives us 225. And we find that our slant height is 15. So now we have pi times 9 squared plus pi times 9 times 15 gives me 81 pi plus 9 times 15, which is 135 pi. Combine those, I get 216 pi yards squared, or about 678.58. Number 22, we start to shift to volume. So volume of the prisms or cylinders. Volume of a prism is base area times height. I'm going to treat this as my base. So the area of the base is 4 times 3.5 times the height, which is 2. Now you may notice we're essentially multiplying all three values. And technically that's true when it's a rectangular prism. But we have to be careful with that because sometimes, like in the next problem, we're going to notice that with multiplying all three values, it doesn't apply. So, back to 22, 4 times 3.5 times 2 comes out to be 28 feet cubed for volume. Now, like I was saying for 23, 14 by 14 triangle is my base. I cannot just multiply all three values because that would give me the area if it was a rectangular prism. Not the case. So it's base area times height. So 1/2 14 times 14 is the area of a triangle, times the height, which is 20. So half of 14 is 7. So 7 times 14 gives us 98 for that area, times 20 gives us 1,960 centimeters cubed. Okay, 24, we're now looking for volume of a cylinder. Well, we started off with this formula for a prism. We just apply the fact that it's pi r squared for a circle. So I take half of this diameter. So half of 2.3 is 1.15 squared times 7.2. So we're just going to do 1.15 squared times 7.2 and get 9.522 pi millimeters cubed. And then we might as well multiply that by pi, and we can say it's approximately 29.91 for our answer. Okay, next we go to number 25. We're looking for the value of x. This is dealing with volume. I have a cube here where the volume is 8. I'm looking for the value, and this is where we can think of multiplying all three values that are multiplied by itself, or cube, to get 8. And if we think about this, it's 2, 2, and 2. That would cause us to get 8, because 2 times 2 is 4, times another 2 is 8. We're going to say x is 2 centimeters. Now, we look at 26, where our volume is our base area times height. 72 is our volume. Our base area is 1/2, 3 times 6. Don't forget the 1/2, because we're talking about a triangle, times x, which is our height. So we solve. I get 72 equals, well, let's see. 3 times 6 is 18. Half of that is 9. So 72 equals 9x. And x comes out to be 8 feet. 27. I have 628 is my volume equals pi r squared times height. So here's 628 equals pi times r squared times 8. So let's first divide 628 by 8, and I get 78.5 equals pi r squared. Now I'm going to divide that by pi and get about 24.99, and then take the square root of that, which we have an idea it's going to be pretty close to a 5, because the square root of 25 is 5. But the square root of that comes out to be 4.99, let's see it here, 4.9987. If we round it, it does come out to be just 5.0 inches. So radius is 5, close enough for our approximation. 28, we're finding the volume of a pyramid. Volume of a pyramid is 1/3 base area times height, just like a prism, but we take 1/3 because it takes up 1/3 of the area. Our base area is a square. It's 12 by 12, so we just say 12 squared. Our height, that is on the inside, is 15. I get 1/3 times 144 times 15. I could take 1/3 of 144, which is 48. 48 times 15 gives us 720 inches cubed. Okay, number 29, we're looking at a hexagonal pyramid, same volume, but we have to first find our base area. So our formula we've talked about is 1/2 the apothem times the number of sides times side length. Number of sides is 6, side length is 5. We now need to find the apothem. So if I cut that triangle out, I have 5 here. I cut that in half. I get the 30, 60, 90, where this is now 5/2. To go from here, I still multiply by √3 and get that. So although it's still a little bit complicated, maybe I made it 2.5 instead of 5/2, and it makes it 2.5 √3. Regardless, we still followed the same process. We took half of that side, multiplied it by √3. So it's 5√3/2. Now I simplify that to find my base area. I can make it 5√3/4 times 30, which becomes 150√3/4. So volume is 1/3 150√3/4 times our height, which is 8. Let's see, we have 150 times 8 is 1200. And that's going to be over 3 times 4, or 12. So 1200 and 12, we can both divide them by 12, and that gives us 100√3 feet cubed, or writing that as a decimal is 173.21 feet cubed. Either one. Again, accurate answer, approximation. Okay, number 30, this is a shifted cone. That doesn't change the fact that the volume will still be the same idea. We're going to have 1/3 base area times height, but our base area is pi r squared times height. So that's 1/3 pi times, well, we're not using 14.6, we want to use 7.3 squared, because that's the diameter, we want half of it, times 11.4. So we're just going to use our calculator for this one. I have 7.3 squared times 11.4 divided by 3 gets us to 202.502 pi meters cubed. Now we'll multiply that by pi, and we get our answers approximately 636.18 meters cubed. On 31, we're looking at the volume of the cone. Now, volume of a cone, like we just talked about, is 1/3 pi radius squared times the height. So far we know the height is 18, but we have to find the radius. And this is where they give us a special right triangle. Now you may remember if this is 90, this is 45, this angle will also be 45, which doesn't mean we have to use a trig ratio because this is in fact an isosceles triangle, so this would also be 18. So I have 1/3 pi times 18 squared times 18. 18 squared is 324. How about I take a third, or divide 18 by 3? I get 324 times 6. 324 times 6 gives me 1,944 pi inches cubed, and we can multiply then that by pi, and we get, it's approximately 6,000, put it up here, 6,107.26, we'll round to. Okay, now we go to 12.6. Our first one is 34. We're looking for the surface area and the volume of the sphere. Surface area of a sphere is 4 pi r squared, so that's 4 pi times 13 squared. That's 4 pi times 169. 4 times 169 gives us 676 pi meters squared. For volume, our formula is 4/3 pi times the radius cubed. So if I do 13 cubed, or 13 times 13 times 13, I get 2,197 times 4 gives me 8,788 pi over 3 meters cubed. Now I can't reduce 8,788 by 3. It doesn't divide. I could check. It turns out to 2,929.333 repeating. I'd rather just leave it as the fraction. That's the more exact answer. But if you want to write it as the decimal place, you would then take this value and multiply it by pi. Number 36, our diameter is 28, so our radius is 14. Surface area is 4 pi times 14 squared. 14 squared is 196. Times 4 gives us 784 pi, and that would be yards squared. Volume is going to be 4/3 pi radius cubed, or 14 cubed, which we get 4/3 times 2,744 pi. Then multiply that times 4. We get 10,976 over 3 pi. It does not reduce any nicer. It would be a decimal approximation from there, so we're just comfortable leaving it as that. Number 38, radius is 20, so surface area is 4 pi times 20 squared. That's 4 times 400 pi. We get 1,600 pi inches squared. Volume is 4/3 pi times 20 cubed. 20 cubed is 8,000. 8,000 times 4 is 32,000. So that's 32,000 pi over 3 inches cubed. Okay, on number 42, we're given a scale factor. We're given a solid A, and we have the surface area and volume of that. And we need to find the values for B, which is the solid similar to it. It's just not shown. So we first start with the ratio of the areas. If our scale factor is 3 to 2, our ratio of the areas is those squared, 9 over 4. I then take that ratio and make a proportion using 324 pi over the surface area of B. So the ratio of the areas, I square from the scale factor. Now that's the proportion to the surface area of B. I then do cross product. 4 times 324 pi equals 9 times the surface area of B. 4 times 324 would give me 1,296. I divide by 9 and I get 144 pi equals the surface area of B. Let's write that a little better. Surface area of B is 144 pi inches cubed. Okay, ratio of the volumes is going to be these cubed, so 3 cubed over 2 cubed, that's 27 over 8. I get 27 over 8 equals 972 pi over the volume. We do cross product. 972 times 8 gives me 7,776. Divide that by 27 and I get the volume of B is 288 pi inches cubed. Okay, 43, same idea. Ratio of the areas. Well, if it's 2 to 1, then it's going to be 4 to 1. So 4 to 1 equals 864 over the surface area of B. I get 4 times the surface area of B equals 864. So the surface area of B, as I just divide 864 by 4, and I get that it is 216 feet squared. Time for ratio of volumes. So I do 2 cubed over 1 cubed, that is 8 over 1. 8 over 1 equals 1728 over the volume of B. I'm eventually going to do the volume of B equals, or 8 times the volume of B is equal to 1,728. Divide by 8. And we get that it is 216 feet squared. Not squared, cubed. Last one for this set. Scale factor is 4 to 7, so my ratio of the areas is going to be 4 squared to 7 squared. Then 16 to 49 is equal to 64 pi over the surface area of B. So 16 times the surface area of B is equal to 49 times 64 pi. I multiply 49 times 64, then divide over the 16, and I'm left with 196 pi centimeters squared. And then the ratio for the volumes is going to be 4 cubed over 7 cubed, 64 over 343. So 64 over 343 equals 64 pi over the volume of B. But you may notice here, if I look at 64 to 64 pi, I really multiplied this by pi. If I did that on the bottom, I would get that the volume of B is 343 pi. If you don't see that, you can always go back to cross product. 343 times 64 pi equals 64 times the volume. Divide by 64, it comes out to 343 pi. Last one, 45. I have 2 similar cylinders that have volumes of 12 pi cubic units and 324 pi cubic units. So let's draw those. A volume of 12 pi, volume of 324 pi. I need to find the scale factor of the smaller to the larger. Right now I can write a ratio of the volumes to be 12 pi over 324 pi. I can write it now as 12 over 324. I can divide both of those by 12, and it actually comes out to be 1 over 27. And now to get to the scale factor, I'm going to take the cube root of both those values. Because this is in cubed, I want just the units, so the cube root of 1 over the cube root of 27. Well, cube root of 1 is 1, the cube root of 27 is 3, so my scale factor is 1/3.